Hi class. In this video we want to build on our previous lectures where we were talking about the normal distribution or the normal probability distribution by talking about the standard normal distribution. And in this lecture what I want to do is I'm going to introduce an example, discuss why we need the standard normal distribution. I'm going to talk about exactly what the standard normal distribution is and how to read our first statistical table in the class. And then in a follow-up lecture to this, I'm actually going to come back and answer the question that I started this lecture with. So keep that in mind that as we work through this lecture, the question that is started or how we introduce the standard normal will come back in another lecture. Okay, so recall this example. Suppose talk time on the iPhone 10 is normally distributed with a mean of 20 hours and standard deviation of 5 hours, right? So the mean talk time is 20 hours. That's this mu, and the standard deviation is equal to 5 hours, and that's this sigma. Okay, so what we're going to do is we're going to select an iPhone 10 at random, and its talk time is going to be recorded. So this is a random variable, so talk time here is a continuous random variable. All right, so we're going to let x be the talk time on that randomly selected iPhone. All right, so here's what I want to do. I want to find the probability. Now, we did some of these questions in a previous section, but this one's a little different. What is the probability that the talk time on a randomly selected iPhone 10 is less than 18 hours? So I want to find the probability that x is less than 18. Okay, so the way you would normally do this is we draw the density curve for normal distribution. Sorry, it's a little curvy there. You know, it's centered at 20. And I'm just going to do a couple standard deviations on each side, right? So 18 is like right here. Okay, here's 18. So what you would do is you would shade in the area to the left because you want to be less than. But notice how it doesn't fall on a nice standard deviation. So we can no longer use the empirical rule here. Okay, so we're going to need a different method to solve this. Okay, so when it doesn't fall on a nice standard deviation, there's an issue. So how are we going to tackle this problem? Okay. And to tackle this problem, we're going to use what's called the standard normal curve. Okay, and this will make more sense in a little bit, but we're going to denote the standard normal curve with a z. Okay, so what exactly is the standard normal curve? You know, when you think of mathematics, what are the two easiest numbers to work with? It's 0 and 1. So a standard normal distribution or a standard normal curve is just a normally distributed variable. Okay, and we're going to call this standard normal variable. We're going to call it z. Okay, and what it has is it has a mean equal to 0. That's awesome. And a standard deviation sigma equal to 1. Okay, so unlike this previous example here where the mean was 20 and standard deviation was 5, this one has a mean of 0 and standard deviation of 1. Okay, and this right here, its associated normal curve, when you draw something with a mean of 0 and standard deviation 1, is called the standard normal curve, which is actually shown not below, but right over here. Okay, so this standard normal curve has the same properties as all normal curves. Okay, the only thing that's really great about it is it just has mean of 0, standard deviation of 1. That's awesome. So just some important properties. So the total area under the standard normal curve is 1. That's how we relate it to a probability distribution. That's That's great. The standard normal curve extends indefinitely in both directions, again, but never touches the horizontal axis. The standard normal curve is symmetric about 0. Okay, so what that means is, the high point of the graph occurs at 0, and they're mirror images on each other. And almost all the areas under the standard normal curve lie between -3 and 3, so almost all the area falls between 3 standard deviations on each side. So what's great about this standard normal distribution is that we can transform. So listen to what it says. We can transform any normally distributed variable like x here into this z variable. And we can do this using what's called the z-score formula. Okay, so we've done this before. Okay, we've done this before in a previous lecture. Actually, we've talked about z-scores. But all it is it's just a mathematical transformation formula. Okay, so any variable you can do what's called standardized version of it. So the standardized normally distributed variable. So the standardized version of a normally distributed variable x. Okay, so any x, like in our example, x here is the talk time on the iPhone 10. Okay, our formula, our z-score formula, is equal to, you take the variable, you subtract away the mean of that variable, and you divide by the standard deviation of that variable. And I'm going to show you, some examples of this formula in a second, okay? And this, when you do that, is called a standard normal distribution, okay? So why do we care about this, or what's great about this standard normal distribution? So look here. So what I have here in these 3 different colors here is I have 3 different three different normal distributions. This first one is a mean of -2 and standard deviation of 1. This second one here in red has a mean of 3 and standard deviation of 1/2. Okay, and this final one here has a mean of 9 and standard deviation of 2. Okay, if you take the mean of each of these variables, okay, and plug them into the z-score formula, okay, it's going to transform that mean to 0. Okay, like if you look at -2, right? So the z-score is equal to the x variable minus the mean divided by the standard deviation. Well, if I take -2 and subtract away the mean and divide by the standard deviation of 1, you get 0. And you could do this with the mean over here and the mean over here. So what ends up happening, if you were to take any variable on any of these curves and plug it into this z-score formula, it would get transformed or related into this curve, the standard normal curve. Okay, so this formula transforms the variable x, so the random variable x, into a standard normal variable. Okay, this z variable. So what's really great about this, okay, is this standard normal variable, okay, on this next page has the same properties as any other normal distribution, okay? So like, let me show you the iPhone example, okay? Okay, x here was normally distributed. The mean was 20 hours, and the standard deviation was 5 hours. And the problem we had, okay, was I wanted to find the probability that the talk time was less than 18 hours. So to do these problems forward, what I'm going to do is I'm going to draw a normal curve. It's going to be centered at 20. And I'm no longer going to tick off the standard deviations. I'm just going to go, okay, I want to be less than 18, so 18 is over here. And I want to shade in the area here to the left. Okay. Now let's talk about the standard normal. Okay. The standard normal is normally distributed. The mean is equal to 0, and the standard deviation is 1. Okay. If I take this z-score formula here, okay, and run it through this value 18, okay, so z is equal to the x value minus the mean divided by the standard deviation. So the x variable is 18, the mean is 20, the standard deviation is 5. Okay, from these numbers over here. So 18 minus 20 is minus 2 over 5. That's minus 0.40. So on a standard normal curve, okay, it's centered around 0. Okay, because that's the mean. If I were to take this z-score, okay, which is the standardized version of 18, and shade to the left of this area and this area would be equal, okay? Okay, so if I could actually just find this area, it would be the same as this area, and I could answer this question over here, okay? So this now becomes, what's the probability that a z-score is less than minus 0.40. These two things are the same answer, okay? Are going to give the same answer. Okay, so now what's the whole point of this? How do I find this right here? Well, attached to this lecture was this table right here, okay? And this is called the standard normal probabilities. And if you look right here, what I drew is I drew a standard normal curve and I shaded some area to the left. Well, look at this. Does this right here look like what I had drawn over here? Absolutely it does. And this is what's crazy. If you look here, here's this z variable, okay? Z right here. So what I want to show you now, just with the remaining part of this lecture, is how you read this table. And then in a follow-up lecture, we're actually going to come back and answer this question right here. All right, so this table has 2 pages, okay? This first one here, you see, just has a little area shaded to the left. This part of the table here works with negative z-scores, okay? And what this does is if you give me a z-score, and I'll show you how to read it, it tells you the area all the way to the left of that z-score. Okay, if I scroll down, this one here looks like there's a lot more area shaded. This table here you use to find the area to the left of positive z-scores. Okay, so negative z-scores, positive z-scores, and the table gives the area to the left. The table gives the area to the left. All right, so using this standard normal table, okay, I want to talk about how you find areas under the standard normal curve to the left. That's easy. To the right, okay, so since the table gives area to the left, the way you'll find area to the right is you just do 1 minus the area to the left. So you just look up the area to the left, and you're basically finding the complement. So you do 1 minus that. If I want to find the area between 2 values, I'm just going to look up the 2 areas of each, and I'm going to subtract the area left of z1 from the area to the left of z2. All right, so what I just want to do here is I just want to walk you through 2 examples of each of these, okay? So you can get used to, or see, so that you can see how to read the table. Okay, so let's do first off areas to the left. So let's find the area to the left of a z-score of negative 1.25. Okay, so what I like to do is I like to draw it, okay? So whenever you see a z, or z-score is referenced, it's going to be the standard normal curve, centered around 0, and I want to find the area to the left of negative 1.25. So I'm going to shade everything to the left. Well, look, negative z-score kind of looks like this right here. So here's how you read the table. It's incredibly straightforward. You're going to need a column value and a row value, okay? The column value is the first two digits. So the first two digits here are negative 1.2. So I'm going to scroll down on my table until I find negative 1.2 right there. Okay, negative 1.2. Then my row value here is the last digit. You see how it's a 5 here? I'm going to find the 5 up here. And I'm literally just going to look where they intersect. So negative 1.2 goes here, 0.05 here, and that red shaded area to the left is 0.1056. Okay, piece of cake, piece of cake. Now let's find this one here. Notice how now it's asking for a probability. Okay, so the probability that a z is less than 0.85. So I'm going to draw it, okay? So here's the standard normal curve. It's centered at 0. So 0.85 is above 0, right? It's to the right, somewhere over here. And I want to find everything less than that number. So I'm going to shade everything to the left. It gets a little messy here, but you get the idea. Well, now it looks like a positive number. So I'm going to go over here on this side, okay? First two digits are 0.8. That's 0.8 right here. And then the last digit again is a 5 up here. So 0.8, and I'm going to scroll over to 5. And that area is 0.8023. 0.8023. And that's it. So reading areas to the left is a piece of cake. All right, now let's find areas to the right. Okay, now remember, whenever I give you an area to the right, you're just going to do 1 minus the area to the left. So you're just going to look up the area to the left and subtract it from 1. So let's find the area to the right of 1.30. Okay. So standard normal curve, centered at 0. Here's 1.30. And we're just going to find the area to the right. So whenever you find an area to the right, it's 1 minus. So I'm going to look up 1.30. 1.3 is right here. And then the last digit is 0. So it's going to be 0.9032. Okay, but that's the white unshaded area. So I want to find the red shaded area, so I have to subtract that from 1. So it's 0.9032. So 1 minus 0.9032, which should be 0. If you plug this in your calculator, you should get 0.0968, I believe. All right, let's do this one. Find the probability that a z-score is greater than 0.75. Well, here's 0. 0.75 is over here somewhere. So I want to find the area shaded to the right. All right, well, again, that's just 1 minus. Now I just go look up 0.75. So 0.7, and then the 5 right here. 0.7, and the last digit was a 5. You get 0.7734. So it's 1 minus 0.7734. Which if you plug this in your calculator, you should get 0.2266, I believe. Okay, so area to the left, you just read right off the table. Area to the right, you just do this 1 minus. Not too bad. All right, this final one, let's find the area between two z-scores now. Okay, so I want to find the area between z is equal to 0.25 and z is 0.125. So I like to draw it. It really helps me understand what's going on in these problems. So z-scores centered at 0. Here's 0.25, it's somewhere here. 1.25 is over here. So I want to find the area between them. All right, so the procedure is you look at the top value, 1.25. So I'm going to find 1.25. So I'm going to go to 1.2, and I'm going to go over to 5. Okay, I picked a lot of 5s as the last digit for some reason in this lecture. I apologize for that. So 1.25 is 0.8944. And then you're going to subtract away. You're going to look up the smaller z-score, 0.25. So 0.2, and then I'm going to go over to the 5, is 0.5987. So just grab a calculator for this, right? Like I'm just going to load up this calculator here. So it's 0.8944 minus 0.5987. And my answer here is 0.2957. Piece of cake. Let's do this one here, the last one here. So let's find the probability that a z-score is between 0.35 and minus 0.55. So I want to find the area, the probability that you're between that. So it's this red shaded area. All right, so let's go look up 0.35. 0.35 right here. So the first two digits 0.3 and then the 5. So it's 0.6368. And then you have to look up, you have to subtract away. Let's look up minus 0.55. So you're going to have to go to the negative side. So minus 0.5 and then over to 5. You get 0.2912, so 0.2912. And then just plug that into your calculator, right? So 0.6368 minus 0.2912, and you get oh, that's interesting, 0.3456. So 0.3456. All right, class, so now we kind of have an idea of how to read this table. What I'm going to do in the follow-up lecture is I'm going to show you a procedure now to go back and answer this question. Okay, and you can kind of see how it's going. And we'll do a bunch more examples of this. And I'll keep showing you how to use the table to find these problems. And then eventually what I'm going to do in another lecture later on is show you how to use your calculator for this. All right, class, thanks.